Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar, just simply to accommodate the rest of the attendees who are in the middle of connecting. Okay, welcome everyone, and thanks for joining us, and thanks for being part of our community. My name is Valen Kolika, and I'll be your host for today. Just a few reminders before we start with this session. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app, please exit and rejoin. This just seems to help in the connection issues. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security webinars. Closed captions in several languages are available during the live broadcast, and you can enable them by clicking on the CC button located at the lower right corner of your screen. Feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your question anonymously by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. However, in the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on our Azure Network Security forum at aka.ms/Azure Network Security Community. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security webinar feedback. And by the way, all the links that I'm announcing have been already shared with you on the chat or the live event Q&A window here. So I would like also to invite you to join our public community by visiting us at aka.ms/security community. That's the best way to ensure you don't miss any future webinars or major announcements. On our community, you can speak directly to our engineering teams that create our security products, and you'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which, by the way, you can also sign up at aka.ms/securityprp. You can request features, give feedback, review our product roadmaps, register for events, or just simply join webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. In today's session, Camila Martins and Anthony Roman will go over the safeguards for a successful Azure DDoS Protection Standard deployment. Camila is a program manager and Anthony leads the PM group for the Network Security GTP team. And without further ado, I will turn it over to them. Camila, Anthony, the floor is yours.
Thanks, Alan.
All right. I'm going to get started, Anthony. I don't know, we've been introduced. Do you have anything to say before I kick off?
I have nothing to add to the introduction.
All right. Well, thanks everybody for being here. I am happy to be talking with Anthony today about some safeguards that will guarantee that your Azure DDoS Protection Standard deployment goes smoothly, steady, and remains that way with time. So we're going to be covering for things such as, the steps to deploy it properly so you can get the best out of the product, and how to then automate some portions of this deployment because things can get quite big and out of control, and how to do some governance for these items so that the configurations remains steady throughout time. I'm also going to do a quick introduction and overview of the service again, just for the people that are not really familiar with it. And at the end of this presentation, we're going to go over a demo to show how and where some of these configurations will be. All right, quick intro on Azure DDoS protection. We have built-in DDoS protection in our Azure platform. This means that whenever you have a workload inside of Azure, it is automatically protected by Azure DDoS. This is something we call Azure DDoS Protection Basic. This is included with the cost of your resources. It doesn't add any additional cost when you're running Azure DDoS Protection Basic, because this is something that applies DDoS protection across our whole Azure data centers. As we are service providers, we are protecting ourselves against DDoS attacks. Now, as you can see here, this would cover for products such as Azure Front Door, CDN, which are PaaS-based services, and other products such as Azure Firewall or Load Balancer, which are IaaS-based services. But then on the box on the left, you can see that we have an added DDoS protection service that's called Azure DDoS Protection Standard. So what is the difference here? Azure Protection Basic applies to everything. Azure DDoS Protection Standard will apply to the IaaS-based public IP addresses, and it will give you some added features. And as we can see in this next slide, you get a few more a few more items of visibility and support and cost protection when you are using DDoS Protection Standard. In this case, you will be paying extra for the service, but that is because it offers you added features. For example, now you are obviously using our Azure Global Network, which can receive a large amount of influx traffic, and will absorb that and be able to distribute it properly, protecting you against volumetric or protocol DDoS attacks. And the adaptive tuning is something that will be adjusting the thresholds specifically to your workloads. When I was explaining about the Azure DDoS Protection Basic, our thresholds are higher because we are protecting our Azure data centers as a whole. In your workloads may need less impact for it to be taken down. So in that case, when you're using standard, the thresholds are adjusted to your specific workloads, meaning that they're going to be a little smaller to protect your applications specifically from an attack. From there, you can also receive visibility on analytics and traffic and metrics with logs. If you are under an attack, you will be able to actually see when it started, when it ended, how large the attack was, which packets were forwarded to the service, and which packets were dropped. You have access to an added service from our support called DDoS Rapid Response. If you're under an attack and you need help for any reason, this is a severity A type of service. You can call in and ask for help. And last but not least, if you were under attack and some of your resources had to auto-scale due to a DDoS attack and we were not able to prevent that, we have a cost protection guarantee on that to assist with unexpected costs. Antonio, sorry, you unmuted yourself. Did you have anything to add in?
The only thing that I will add is for anybody that's interested in kind of a longer form explanation of all these features, this portion of this webinar is just meant as a refresher, a quick overview so that everybody's caught up. But if you want a long form explanation of DDoS Protection Standard, including a full live demo of a simulated attack and all the different data and everything that was just explained, you can go to our previous webinar recordings. There was one that Camila did last fall that is, I think, all still completely accurate. That no major features have been added since then. So that's current information, and that the link is in the chat already. It's aka.ms/security-webinars. So,
yep, and just look for I think it's a DDoS deep dive, and we'll go into further details for sure. All right, so let's move on here. Now, what are the steps, just quick steps that you would go through when you are enabling DDoS protection standard in your environment? The first step is that you have to create a DDoS standard plan. And from the moment that you create a plan, that's the moment you get charged for this extra service that you're now using. So once you create a plan, the next step is attaching the VNets that you want to protect to that plan. So it doesn't become, all of your VNets don't become attached by default. The plan is alone, it doesn't do anything by itself. You have to say, I want to protect these VNets with a plan and attach them to that plan. And then another layer that is important to know is that the resource we're protecting with DDoS protection are public IP resources. And in Azure in general, none of our resources will do diagnostic logging by default either. So you have to explicitly ensure that you enabled diagnostic settings for the public IP resources. Because what happens here is that one of the features you're paying extra for is to have visibilities, to have access to those logs in case something happens to your public IP addresses. If you don't enable the logs in the public IPs, and you do go through like an attack, technically you will lose that visibility. The logs won't be automatically generated. So you have to go through these 3 steps to make sure that you're getting all of the benefits from the service. And of course, now we need to ensure that all of our public IPs are configured properly with diagnostic settings enabled, so you get the visibility. So what happens and why we're having this webinar today is, well, it sounds simple. Technically, it's a very easy implementation. You create a plan, you attach your VNets, you enable logs on your public IP addresses. That's pretty safe. But we're saying, well, in a real world, I can have a single plan that makes life easy, that's fine. But then how many VNets do we have? Like we can have 10 VNets, we can have 100 VNets. I don't even know, it could be thousands. So how do you have an admin that's going to be adding 1 VNet at a time to your plan? No, it doesn't work. So there has to be some type of automation that you do to ensure that you can configure a large amount of VNets in mass all at once. In a similar fashion, which gets even more complicated, is when you're configuring the diagnostic logs on your public IPs. Because again, diagnostic logs in Azure are configured at a resource level. So each resource has to have that setting configured in it. So now we're talking, as many public IPs as you might have, you have to ensure that every single one of those has the diagnostic settings configured. It gets like a lot of manual effort for us to do this. And this is why we're talking today on how to automate this and make it much simpler. And from an
Sorry, I'm just going to add that it's very easy for us, and we've done this. I would say we're guilty of this in some circumstances. It's easy for us to bring up the Azure portal and show you how to create a plan and attach a VNet to that plan, and then show the diagnostic settings on one single resource, and that's fine. But that's not fair. It's not a fair representation of the real world, an actual environment. And so, if you're out there looking at, watching another webinar or a quick demonstration from somebody and saying like, okay, that seems easy. Now let's go make that real in a production environment. It does not scale. So that's why we're here, and that's why we need automation and we need governance.
Yes, and then that's where we're going next, like the governance part. You're like, okay, so I have this pretty little box here with a check mark on it. I'm like, oh, I went through all the work. I created a plan. I attached my VNets. I configured my IPs. It's all nice and protected. But as we all know, our environments are not static. I am pretty sure at some point there will be new VNets that somebody created. I'm pretty sure that at some point there will be new public IPs that somebody created. And if when these VNets get created, they don't get attached to your plan, if these IPs get created and they don't have the logging enabled on them, you're right back there. They are in your environment. You maybe think they're being protected, but maybe you have like half of them are configured properly, the other half is not. And just a quick thing I want to mention here too is that when you are using DDoS standard, this is a tenant level product. So that means that with that single plan, any subscriptions, like all of the subscriptions under your tenant, can actually use that plan. So now we have another layer here saying, well, sometimes subscriptions are managed by different business units, or you have different IT groups. How do you get everybody communicated to use a plan? How do you make sure that these units that may be completely decentralized are following that configuration that we want them to stay protected for? It could become difficult to do it, obviously, manually. So there are ways also to improve the governance without having to go through so many manual steps. Okay. So step one here, we have added a built-in Azure policy to our environment as an offering in Azure that will then ensure that all of the VNets in your in the scope that you apply this policy to will be attached to a DDoS plan. So that means that you have an option to say just audit or modify. Meaning, if you're just auditing, you get to have a big snapshot saying, oh, I get now I know which VNets in my environment have a DDoS plan attached to them or not, but it doesn't make any changes. But you can also deploy this policy in a way that you can actually modify the settings, saying, well, I realize there are some VNets in my environment that don't have the DDoS plan, and I want to go ahead and actually add that configuration to them. So this is something that can help you remediate, policies that are not using your remediate VNets that are not using your DDoS plan, and also ensure that anything created from that moment on are in fact using your plan. Another policy that has been added to our environment, which will also help you ensure that things are configured and running smoothly, are the ones to enable diagnostic settings for your public IPs. In a similar fashion, it has different effects. So we have an audit if not exists, or a deploy if not exists effects, but the concept is similar. So it's looking at your public IPs and it's saying, well, if my diagnostic settings, saying my logs, are not enabled for my public IPs, let me know. So you do get a list, you get a big, huge, holistic view of which public IPs are not configured properly. And you can go a step ahead and say deploy if not exists, meaning if somebody creates a new public IP and it's not there, I can actually make those settings and push those settings to be deployed to that public IP. And in this case here, you also get to decide what your diagnostic settings will be. So you get to determine which log analytics group they're going to go to, if you're going to be enabling logs, metrics, or both, and you make those decisions in your policy and push them to your environment. Any comments, Tony, before I move on?
Yeah, the only thing I want to say here is that you know, we jumped straight from automation, governance, the need for either, and then we jumped straight into Azure Policy. And I'll give a little background on why we went straight to Azure Policy. The big reason, and you can accomplish the automation aspect of what we're talking about with many different forms. I mean, you can use PowerShell if that's your flavor of choice. You can use PowerShell to script the deployment of all these things, and you can do that very easily. I've done that in large customer environments where we need to deploy DDoS protection, and we need to just get the plan created, the VNets added to that plan, and the diagnostic settings run, and we have scripts to do that. But that doesn't solve for the governance piece. Same thing with Azure has publicly available REST APIs that, if that's your method of choice, you can automate this with that. You can use Terraform. There's plenty of ways that you can programmatically interact with Azure that will allow you to do this. The reason that we concentrate on policy is that it's really it's platform native, and it really is the easiest way to accomplish both things in one task. So when you assign an Azure policy that does what she's demoing here, which is either attaching VNets to a plan, or whether it's enabling diagnostic settings, the policy does both things. It will automate the initial deployment to get things in compliance, and it will keep things in compliance in the long term. So it achieves both ends that we're trying to get to here: automation and governance. And so that's the main point that I want to just make sure that we're making there is Azure Policy, we believe, is the best tool for the job to accomplish both automation and governance. There's other things that you can use, but we won't go in depth into those things, because I think everybody here within this team agrees that Azure Policy is the right tool for the job.
Nice. Okay. So changing gears a little bit here, I was pretty focused on some of the technical aspects of make your deployment run smoothly and ensure you get everything all of the features are there to provide you everything you want from them. But we have added, and this one is not a built-in policy, it's a custom policy, which is in our GitHub as a sample if you guys are interested in using this. But this is more about cost protection. And I know we're technical and whatever, but cost protection does matter. We all know that we are on budgets. And the way that the DDoS standard price model works is that they have a fixed, flat fee for as a monthly charge. And that flat fee covers for up to 100 public IPs. So if you have under 100 public IPs across your whole tenant, any subscriptions, it doesn't matter, you're paying a single flat fee. But what happens that we unfortunately we've seen some customers do is that sometimes they don't have that understanding that they only need a plan that can be distributed across, a single plan can be used by any subscriptions. They sometimes think that each subscription should have their own plan, and they are well under that 100 IP limit, but they deploy 3 plans, 4 plans. So that means that they would be paying 3-4 times more that monthly fee, because you pay one plan is one monthly fee when they were not in fact needing it, right? So how can you make sure that at least the unnecessary added costs are happening? So if you have you've done an analysis of your environment, you have an understanding of the quantity of public IPs you have, you understand how much it costs, and you can say, well, it is enough for me to have a single plan. I don't need to have more than one plan. You can use policy to deny the creation of plans to everyone except for a particular subscription or a management group or a resource group of your choice. So again, you can scope that down when you're configuring your policy. And then you can say, you know what, no one can create a plan, so that way I will not be charged, except this resource group that is the one, my central IT or my central security or my central billing group, I don't know. That one can create a plan, and that's there. So when somebody tries to create a plan, you can even give them a custom message saying, you're not authorized to create a plan. Please use this plan, name here. And that will definitely help with controlling some of unnecessary cost if this ever happens in your environment. Here's something we want to talk about is how to validate your implementation by using simulations. So we have a partnership with Breaking Point Cloud. You can sign up for it, and you get a few gigabytes for free. And this will allow you to actually attack your own public IPs from Breaking Point. And by doing so, you get the opportunity to see if your configuration is working properly, the response times, the logging, the reporting. If you get to create any type of automated responses that we're going to cover right after this, you get to see if that triggers properly. So it's very good to be able to validate if everything is working as expected for a variety of reasons. And besides, I think, Anthony, you added talking about the Breaking Point APIs with Python scripts here.
Yep, and we have that published in our GitHub repo. And I think that one, that's not for everybody. You might not want to automate the actual validation and testing. But for organizations that want to, I guess, maybe keep those involved in their tabletop exercises or actual red team, blue team type exercises. If you want to keep them on their toes and run an automated test against your infrastructure at some random interval, then that's an option for you if you wanted to go that way.
Oh yeah, you're going at a more like unexpected type of a surprise.
Yeah, if you're mad at your blue team that day, then cut it up, strip it off.
I mean, I can see that. I I've had customers do that. Then you really truly know that the response is on top, on top of it. Okay. Now, so again, this service is pretty self-healing. Whenever DDoS realizes that you're under attack, it has a threshold that it sets for you. It sets that threshold for you based on a combination of the traffic that your service normally receives with the capacity that your backend can handle. It creates this threshold. When it realizes that there is more traffic than usual, it will already kick in the response by starting to mitigate your service. It will automatically drop or forward the packets depending if they're good or bad. So truly, and after the traffic dies down, the service stops. Like it's just pretty automatic. It's fairly hands off, but that doesn't mean that you don't have response procedures. Even if the service is pretty much doing the whole work for you, you may want to report on it. You may want to have awareness that this is happening and look at other resources and see if there maybe is, there's other types of attack occurring concurrently with a DDoS attack. So there are several ways in which you can execute some response procedures. And we have a few examples here. For example, if you are interested, you remember that you can always contact the rapid response support. You have the option for you if there's a need for that. So you could execute that as a response. You could also, if you're using Azure Security Center, there is a built-in security alert in there that will also provide you visibility that you're under attack, they are currently mitigating an attack. So you can configure those security alerts for any further actions from Security Center if that's something that makes sense for your teams. Inside of Azure, now that you have logs, you can create workbooks. You can use Azure workbooks either in Azure Monitor or in Azure Sentinel if you're using that. But the workbooks will give you preset queries. You can customize them, but we have them published out there with the most common types of patterns that we want to look at. So you can see, the types of attacks that went through, the amount of packets that were dropped, the countries that are attacking you. And the workbooks are interactive, so you can actually filter them down. They will they will automatically adjust when you're digging in for investigations. So it's pretty useful for SOC analysts. Last but not least, if you are in fact using Azure Sentinel, there is a connector available for DDoS standard, which will consume those logs, and then you can enhance your response, for the DDoS attack, because by using Sentinel, you get to do like the playbooks, besides the workbooks, playbooks and analytics that we can give you even automated responses if you configure that. Anything to add here, Anthony?
No, and I think this is kind of a segue into the next slide, but for the most part, unless somebody can think of a compelling argument to do something in response to a DDoS attack other than just wait for the protection that you're paying for to kick in and mitigate that attack. For the most part, all we see customers wanting to do in terms of an automated response is really just letting the right people know. It's more of an awareness response. It's less of, hey, we need to shut this down because Azure's going to shut it down for you. For the most part, you don't. If you've got your things working correctly, your service is going to scale out anyway to handle a little bit of increased load while we're working to mitigate the attack. So it's less of a you have to start investigating and stopping that traffic. You just wait for Azure to stop the traffic, and you just monitor your app to make sure that it stays available, and that's really all that needs to be done. So that's that's kind of there's your segue into what might you want to automate.
Yeah, this is a sample we have with some automation. We have created a logic app that will provide an email alert with enriched details. Sometimes out of the box, some of the alerts can be a little too simple, like they may not provide you a lot of details of what really happened, or which workloads were affected at what time, etc. So with this logic app, which is also available at our GitHub repo, you can configure, if there is an event happening, mitigation is occurring, you can configure this logic app to send an email to the resource owner, to the specific resource owner defined for the resource that is being attacked, and you're going to have a larger list of details there. So when they are, notified, so they have awareness of what's going on in their environment, right from that message, they already have all the details that they need to start any other possible procedures that they may want to execute from that moment on. And I think that was my last one, Anthony. I don't know if you want to add a little more on the enriched alerts, but then we can move on to the demo.
Sure. Yeah. So the enriched alerts, I think this is a logic app that I wrote in response to a request from a customer that had specific requirements around who they wanted to notify, what they wanted it to say, what sorts of things they wanted to be easy, because the question came around because there's the SOC analysts that would normally get an alert from, hey, this is a potential DDoS attack. Normally, all we really include in that message that comes from Azure Security Center by default, which, by the way, even if you're not using Azure Security Center standard or the kind of the Defender SKUs within that product, you will still get a DDoS protection alert via Security Center if you're under an active attack. And so that alert by default really only contains the public IP address, and it's up to the analyst to figure out what is behind this public IP address. What is it? Who owns it? And so the request that came into us was, well, we want to know, and this is the reason that we kind of keep that alert simple in the first place, is that every environment's different. Every team has a different response procedure, and every team is going to want different information. So this was created just as an example based on some, a couple of customers' requirements that they said, listen, we want to, if this is a web app, we want to know whether that web app is up. We want to know, what's happening with it. We want to know who owns it, and we want to inform that person, whoever owns that resource within Azure, hey, your resource is under attack, and you need to maybe just monitor that your app is live and it's running, and that there's nothing that you need to intervene in. And so what this does is it requires a few things to be configured, including you have to have a tag, an owner tag that's on the resource, on the public IP address specifically. So there's built-in Azure policies out there that will assign all resources within a specific resource group the same tag based on who owns that resource. at least that resource group. So in this case, you know, if the public IP address that is under attack is owned by whoever it is, maybe it's your application owner, that application owner will get emailed along with your SOC team, and then you'll have a quick canned, here's just the HTTP status that comes back from a simple web request. It's not that advanced. If you have you know, apps that you're particularly concerned about, then you can build in your own actual test, you know, and have it spit out something a little bit more meaningful. This was just like with anything that you'll find on our GitHub or really, you know, anywhere else. It's there as a template. It's there for you to take a look at and say, okay, 90% of this applies to my environment, but I can take that last 10% and tailor it to my needs. So feel free to dissect this and you know, tailor it to your own environment. And I guess with that, if we have, I think we have no more slides other than the one that says demo. So I will demo. So let's see. Let me find my Azure portal. And now, so everybody should see my Azure portal. And there's a few things that I want to take you through for the demo. Specifically, and I guess primarily my focus is going to be on understanding how to use the various Azure policies that were highlighted within the slides so that you can see how to make them work in real life, in a real environment. And of course, this is a demo environment, but it approximates at least something that might make sense in real life. So I'm going to go into my DDoS protection plans and just kind of show you some of the elements that make up a DDoS protection deployment. So you can see this is our existing DDoS protection plan. It's already there. I'll go ahead and try and make a new one. And if I put it in just some generic resource group, I'm going to go to review and create. And what we'll see here is that the validation of this deployment failed. And if I click on here and figure out why, I can see that this is disallowed by policy. So this is one of our policies in action. This is that deny policy that inhibits resource creation if it does not meet certain criteria. So basically, in this environment, we've said, we've got DDoS covered for the entire tenant. You don't need to worry about it. So if anybody, you know, if you have some do-gooder on your staff that's, you know, very concerned with network security and says, well, I just stood up a resource and I think it needs DDoS protection. And you do have the option to actually attach a DDoS protection plan when you create a VNet and create a new one even. And so if somebody says, well, I want to create a new plan because that they don't know how the whole thing works, this will shoot them down and say, and you can customize this message as well. So it says, reason you're not allowed to create a plan, please use the existing plan. You can actually specify that plan by name if you want to, or put in a contact who owns the specific subscription that central plan lives in. You know, if maybe you haven't delegated the right resources, the permissions to attach that plan. And quick point about RBAC versus policy. That's an important distinction because in this instance, this environment that I'm demoing from, I'm a subscription owner or at least a contributor. But as you can see, under normal circumstances, I'd be able to create whatever resource I want. But in this circumstance, this deny policy has it basically overrides the RBAC permissions that I have assigned to me. Policy is more powerful than permissions. So that's something to keep in mind, that even if you have the need to delegate more permissions to a certain group of people or individuals, you can say, well, no, not in this situation. You should not have that permission, even if it's granted in others. You can create a deny policy that overrides that. So that's an important thing about policy to keep in mind. Close that out and see. Okay, so let's go back to our DDoS protection plan. And in this existing plan, we can see under protected resources. Let's see what we actually have protected. I think we may. Okay, so we have 2 virtual networks that are attached to it now. And I'll go through and show you a little bit more about these networks. So out of these virtual networks, we have 3 total virtual networks in this particular resource group. two of which are protected by DDoS protection. This third one is not, and I'll show you why only 2 out of 3 are protected. The built-in policy, and let me go back to policy. So when you're in Azure Policy, and I want to spend a little bit of time. I'm going to try not to get too carried away. So somebody, say something if I'm going down a rabbit hole, but I want to give a decent explanation or an attempted explanation of Azure Policy, all of kind of what goes into creating one, understanding one as it's written, and then applying it in some way to your environment. So we'll see if we can get through all of that. Maybe it's a lofty goal, but I'll see what I can do. So when you look at your Azure policies, and I have this filtered already, I'm already searching for the word DDoS. So I'm only filtering on the DDoS related policies that are in my environment. And you can see under this type column, there's custom policies and there are built-in policies. The built-in ones, as the name implies, those come within Azure. You don't have to, they're just there. The custom ones are either modified versions of these built-in ones, or they are ones that you may have written from scratch. Writing a policy from scratch is not something I would recommend. It's not for the faint of heart. For the most part, just like any any code-like thing that you might write, copy and paste is your best friend from reputable sources, please. But let's take a look at one of these just so that we can see kind of what it does. So let's take a look at this. The virtual network should be protected by Azure DDoS Protection Standard. When you click on any of these policies, what you will see is the definition. So there's a couple of concepts to know. Definitions and assignments are the 2 most important concepts within policy. The definition is what the policy does. The assignment is what that policy applies to. And we'll assign one of these policies, or at least take a look at an existing assignment so that you can see how those 2 things work. Now, Azure Policy, it looks, so it's vaguely in JSON format. So, some key value pairs and nested objects and things. And it's very similar. Some of the things that, one of the concepts that you really need to understand in order to understand how a policy works and how it looks for different resources and interacts with the resources in your Azure environment, you need to understand ARM. So Azure Resource Manager, I'll take a look at, I'll demo one of the ARM templates from one of our VNet resources, so you can see how this policy will read that resource, how it will understand it, and then how it will affect that resource once we get to that point. But ARM is, I hope that a lot of the attendees here already have a good conceptual understanding of ARM. And if you don't, I highly recommend researching and doing some tests with ARM templates, or at least understanding what an ARM template of an existing resource looks like, because that's how policy understands things. ARM is basically, it's the language of Azure. So if you understand ARM, you can understand Azure at a more fundamental level. All right, so back to this policy. There's a bunch of fields here that I can kind of skip over because they're basic. Display names, the policy type. This is a built-in one, description, etc. The important parts of the policy are as follows. Parameters is one. These are the selectable fields that you will be given when it comes time to assign this policy. So and these parameters will be used down below in the policy. We have the effect of the policy. This one's really important. The effect of the policy is what it does. So this particular policy will either modify an existing resource, or it will audit, which, just read on it and report it, or it will be disabled. So effectively, you have 2 main effects of this policy: modify or audit. Do you want it to do something, or do you want it to read something? Now, when you read further down, and we also give a parameter on this one for you to enter the DDoS plan that you want to attach VNets to, because this, after all, the purpose of this is protecting networks with DDoS Protection Standard. So we'll get to exactly how that works in a minute. The policy rule itself is an if-then statement. So you can see, and it gives you, it's actually a decent editor in here. You can select one of your brackets and you can see what's included in that bracket. So within the policy rule, we can see everything that's highlighted here. There's an if and there's a then. So a conditional that says, if all of these things and any of these things are true, then this down below will happen. So in this case, if a resource is of the type Microsoft network.network/virtual network, so if it's a resource type of virtual network, and these you have enabled DDoS protection is true, or it does not equal true. So if DDoS protection is not enabled and this field is, a double quote next to another, this is a null value. So if there's no DDoS protection plan that's associated with that and it's disabled, then we want this to happen. And so the operation that happens here is an add or replace, and we add these couple of fields. So we're going to change this field to true, and we're going to add in this parameter from the beginning, which is the DDoS plan that we want to attach to this network. So in a nutshell, that is what this plan does, or that is what this policy does. Now, if I have the desire to do something slightly different than this, I can always edit this definition. In this case, I can't edit a built-in one. I would have to duplicate it and then edit that duplicate, which I've done. And here's one way that you can do it is find a reputable source. In this case, the reputable source is our repository that we've linked to a bunch of times. So the Azure Network Security repository. And ignore this. Yes, I was committing while we were on the webinar. But what we have here is pretty much a carbon copy of this. But what I've done with this one, and all you have to do if you go back over here, and if you decided that you wanted to duplicate this definition, edit it, you could just copy and paste my definition into this one and create your own policy. And I'll show you the version that we've created. The difference here, the only addition that we have here is I've added a couple of parameters, which is a tag value and a tag name. And I've modified the policy rule to look for that particular tag that we're specifying. So in essence, what we're saying is instead of this policy that says all virtual networks need to be protected by Azure DDoS Protection Standard, I'm saying I want this policy to apply to all virtual networks that are tagged in a certain way. So we'll see what that amounts to. So let me go back to here. So we have, if you remember, I have this hub and this spoke are protected by DDoS protection. This dev VNet is not. And the reason, and I can show you why. So environment, ENV, short for environment. Environment is dev here, and on these ones, the environment is prod. So this is an example that you will see in real life that maybe is the case in your environment, and maybe it's not. Sometimes customers have an environment where there's a whole subscription dedicated to all production resources, and you want everything in production protected by DDoS protection. Fine, easy. You don't have to do it tag-based. But sometimes you have a subscription or even a resource group that has different types of resources, and maybe it's not a production versus dev question. Maybe you just want certain resources based on whatever. The tag thing is just an example. Again, anything that you find in our GitHub is meant to be modified by you to fit your use case. So if you decide you have some criteria, maybe it's a particular owner, maybe it's a particular location, anything that's in our case here, like maybe anything that's in West Europe, we know that that's where our production, our high value applications that we need available at all times live. You can put a location parameter in here and select that instead of tags.
Yeah, I saw customers do tags based on like actual standard requirements that they have. So if they're financial or health, and then they have to comply only with a particular set of apps, they're like, you know what, these ones need it because we need to comply, but the other ones don't. So that's another use case.
Yep, exactly. So Yep, take this concept and apply it to however it works in your environment. So I'm going to look at some already deployed policies. So if I, in this case, I actually do have this policy assigned, and so I'm going to just go in here and search for DDoS. Oops. And so here's my tag-based policy that exists in my environment, and I do have it assigned, and we can see, let's see, edit the assignment. So when I go to assign a policy, I assign it to a particular scope. And in this case, I'm assigning it, you can be as granular as the resource group in your policy assignment. You can assign it to either an entire subscription. So my subscription here is called build environment. And then this is our CXE webinar resource group. So this is, I've scoped this policy right down to that, that resource group. In my case, of course, I wanted it more granular than that. And I said, all right, I've got some VNets I want to protect within that resource group and some that I don't. And so I did that with tags. Here's where I set my parameters. I know I want to look for, I only want to protect my environment of production. Here is the resource ID of my DDoS protection plan, and I do have it set to the modify effect. And in order to do a modify or a deploy or something like that, you need to create a remediation task. And this is one of the requirements. So if and I'll show you what this means in a second, but as long as a remediation task is created, when this policy evaluates your environment and it looks for, again, with our policy, it says, let's look for everything that's a virtual network that is, tagged a certain way and does not have DDoS protection enabled. When it finds those non-compliant resources, then it will create a remediation task automatically. And this is what does that, automatic, the automation and governance piece. So you'll find your non-compliant resources, and this policy will go ahead and remediate those automatically. And that goes, this remediation happens every 24 hours. So what you're doing is you're not restricting anybody's ability to create new VNets. You're not saying you must not have non-DDoS protected VNets and public IPs out there. You're saying go ahead and create what you want, and our governance will kick in later and say, oh, I found a non-compliant VNet. We need to add DDoS protection to it. And again, you can customize the non-compliance message if you need, and then save that off. We'll go back to the policies, and I want to show you what it looks like when you search for, when you take a look at what the compliance of this resource is. So, and search for DDoS, and we have a few different ones. We can see I have 3 DDoS policies assigned to this environment. I have the restrict plan creation, which we already saw its effect. That one denied my attempt to create a new plan. I have virtual networks should be attached, should be protected, and this is the tag-based one. And then I have the public IP address resources should have resource logs enabled, so diag logs. So let's take a look at one of these. We'll go into the virtual network protection one. And this is going to drill into the policy compliance. And we can see now all 3 of these VNets that we have in this environment are compliant. And we can click on the details and see why it's either compliant or non-compliant. In our case here, we can take a look at the remediation task, and we can see that, yes, in fact, a remediation task did have to be run, and 2 out of 2 resources that it was run against succeeded. So we can take a look at this one. Oops, that just links me back there. I can take, oops, keep clicking when I shouldn't click. And if we view that remediation task, we can see exactly what it did. In this case, this ran, and you can take a look at the policy and the definition of that policy to find out exactly what ran against this. But we can see that this in fact succeeded. If there were any related events, they would be linked to here, but you can drill into any issues in remediation. You know, if something is poorly written in the policy and just didn't account for certain certain pieces of your environment, then you can troubleshoot that way. But in this case, we're all good. I have 3 compliant networks out of 3. And then this last one is the logs, and we can see on this one we have all compliant resources. These are 3 different public IP addresses that exist within my environment. And in the remediation tasks, I can see again I have 3 out of 3 were remediated. So when this policy was applied, or maybe when these resources were created after that policy already existed, they were the resources were created with no diagnostic settings enabled. And now we have 3 out of 3 resources that do have them enabled. And by the way, the best way to centrally view your diagnostic settings is to go directly to Azure Monitor and go into diagnostic settings here. And you can do this on a per resource level, but I like the central view here so that you can see really in you know, I think it's worth any security practitioner out there's time to take a look at this view, this exact view right here in your environment. This is every single resource in my subscription, and I can see that, you know, if I'm a security admin, honestly, in this subscription, red flags would go off immediately because I have a whole bunch of storage accounts that don't have resource logs, so I'm not seeing anything that's going on there. Okay, so I do have diagnostics enabled on my VNets. That's good. But there's all kinds of other resource types in here that I do not have diag logs enabled. I have very important diag logs enabled. I have my firewall logging, my app gateway is logging. I have some public IP addresses that are not logging, so these must not be in scope of what I'm trying to protect with my DDoS plan. But if you want to, you can get a little bit more granular and say, I want just this, and I only need to filter that far. So within this webinar resource group, I find my 3 different public IP addresses, and I see that their diagnostic settings are enabled. And this is what you want to see in a DDoS deployment. And I can see, in this case, I'm only logging to an log analytics workspace. But I do have the options to log to an event hub for an external SIM or a storage account for long-term retention. And if you click on the details, you can see that I'm logging all 3 main categories of DDoS protection logs plus all my metrics. So in this environment, I have all my policies working together to both get me compliant and keep me compliant. So hopefully I didn't go too overboard there on explaining all the intricacies of policy. You can spend hours and hours reading about all of the different options in policy, Azure Policy configuration and writing. But hopefully that 5 minutes or so of Azure Policy tutorial was worth it. And I guess I'll stop there because we only have a couple minutes left, and maybe we have any questions, or we can just be done.
I'm swapping back to our closure slide, if that's okay.
Go for it.
Great. Well, we do have like 2 minutes if anybody has any questions. I don't know, Valen, if you have any closure statements.
Yeah, there's still 2 unanswered questions that perhaps we can tackle. So one of them is, what happens to Azure DDoS protection policies and settings in a scenario where I would like to transfer Azure resources between resource groups in different Azure subscriptions? Do I need to recreate all my Azure DDoS settings, or will they be migrated to the targeted Azure subscription?
The current settings, however that resource is configured. So, you know, I didn't have time to take you through like what the ARM template of you know, a properly configured resource looks like. But once that modify operation has happened, once that VNet has been attached to the plan, and once your public IP addresses have diagnostic settings enabled on them, that configuration doesn't change. That follows that resource. Now, if that resource lands in a resource group or a subscription that's outside the scope of your policies, then you might be able to modify those and have them not come back to where you want them. So ideally, what you would need to do is make sure that your policy assignment scope is broad enough to still apply to those migrated resources.
Well, cool. Thank you for that. It looks like the rest of the team is taking care of the next two here, and that's great. Thank you, team. Thank you, Camilla and Anthony, for an excellent presentation, and thank you to the rest of the team who's been taking care of all these questions that came in. And I would like to remind the listeners that the best way to ensure that you don't miss any future webinars or major announcements, please to visit us on our landing page at aka.ms/security community. And while you're there, you'll find easy ways to navigate and find the resources and learning content relevant to your security needs and products. A good start, perhaps, would be by browsing our bite-sized product videos, the Ninja trainings, as well as the recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve on these webinars, and please take your time by submitting your feedback at aka.ms/security webinar feedback. And in case we missed to answer your questions, or if you have additional questions, you can visit us. In fact, you can visit the Azure Network Security Forum at aka.ms/Azure Network Security Community. I want to thank all of you for being part of our community and for joining us on these webinars, and we hope to see you next time. Goodbye.